It was analyst and writer June Singer who said, "It is insufficient that you have learned to drive a car, or shall we look and see what is under the hood? Most people go through life without ever knowing." In this lesson, we're going to write, interpret, and use the distance formula, and we're going to use the formula for a relationship between distance, fuel economy, and gas usage. All to answer the question, what data are important to a driver? Before we get into it, let's make sure we're ready for this lesson by looking at warm-up number 2. The volume of a cone is V is equal to 1/3 pi r squared h, where r is the radius and h is the height. First, let's solve for r. To solve for r, what we can do is take everything that is not r and divide the other side by it, so that we have V divided by 1/3 pi h. Now this would be equal to r squared, but we have that squared. So let's take the square root of that side, leaving r by itself. Now let's solve for h. Similarly, everything in that right side of the equation that is not h will be dividing v, so that we have v divided by 1/3 pi r squared, and that's now equal to h. Now, let's take a look at a problem that you will be able to do by the end of this lesson. David knows that the price of gas in his hometown is about $2.30 per gallon. How can he compare this price to the price paid in example 6 per liter? David needs to express the U.S. gallon price as a U.S. per liter. There are approximately 3.8 liters in a gallon, so we're going to divide the price per gallon by 3.8 to determine the price per liter. So 2.3 divided by 3.8 will give us approximately 0.61. So his hometown gas price is equivalent to about 61 cents per liter. So gas is more expensive in Mexico, being that is less than the 76 cents per gallon in example 6. Now, to compare the price in peso, we're going to multiply the amount in US dollars by the exchange rate. The exchange rate for that problem was 18.66. This is going to give us 11.38. The gas in his hometown would sell for about 11.38 Mexican peso. Just as the comparison in US dollars showed, the comparison of Mexican peso showed that at this particular time, gas is more expensive in Mexico because 11.38 is less than 14.25. The dashboard of an automobile is an information center. It supplies data on fuel, speed, time, and engine operating conditions. It can also give information on the inside and outside temperature. Many cars now have a camera that shows what's behind you when the car is in reverse. Some cars have a navigation system built into the car's electronics, as well as optional internet access. This can help the driver to find destinations on maps or alternative routes. Your cell phone can be wirelessly connected to your car so that you can use your phone hands-free. There have been many advances in the information that a driver has available to make trips safer, smarter, and more fuel efficient. The odometer indicates the distance a car has traveled since it left the factory. All automobiles have either an electronic or a mechanical odometer. Some dashboard odometers can give readings in both miles and kilometers. An electronic odometer gives the reading digitally. In older cars, a mechanical odometer consists of a set of cylinders that turn to indicate the distance traveled. Many cars also have a trip odometer, which can be reset at the beginning of each trip. A trip odometer gives you the accumulated distance traveled on a particular trip. The speedometer tells you the rate at which the car is traveling. The rate or speed is reported in miles per hour, mph, or kilometers per hour, kph. Drivers are concerned not only with the distance traveled and speed, but also with the amount of gasoline used. Gasoline is sold by the gallon or by the liter. Over the past 20 years, the price of gasoline has changed dramatically. Economizing on fuel is a financial necessity. Car buyers are usually interested in the fuel economy measurement. These are calculated in miles per gallon or kilometers per liter. In order to understand the fuel economy measurements, it is necessary to have a good sense of distance in both English standard system of measurements used in the United States and the metric system of measurements used in most countries throughout the world. A mile equals 5,280 feet. A meter is a little more than 39 inches. Driving distances are not reported in feet or meters, but in miles and kilometers. A kilometer is equal to 1,000 meters. Miles and kilometers can be compared as follows. 1 kilometer is equal to approximately 0.621371 miles. And 1 mile is approximately equal to 1.60934 kilometers. The distance from Seattle, Washington to Vancouver, British Columbia is approximately 176 kilometers or 110 miles. Miles per gallon is a unit of measure that gives the number of miles a car can be driven on 1 gallon of gas. A car that gets 28 miles per gallon can travel about 28 miles on 1 gallon. A car that gets 11.9 kilometers per liter can travel about 11.9 kilometers on 1 liter. There are about 3.8 liters in a gallon and 0.26 gallons in a liter. When shopping for a new car, always ask for fuel estimates. A smart automobile owner is aware that a working knowledge of driving data can help reduce the cost of automobile ownership. Here, we're going to learn how to use and interpret driving data. Now, let's write and use the distance formula. A car travels at an average rate of speed of 50 miles per hour for 6 hours. How far does the car travel? The distance that a car travels is a function of its speed and the time traveled. The relationship is shown here as the distance formula, where d is equal to the rate times the time. Where d represents the distance traveled, r represents the rate at which the car is traveling, and t the time in hours. So for this particular problem, we get that d is equal to 50 times 6. So the distance traveled is 300 miles. Now let's check your understanding of this. A car is traveling r miles per hour for m minutes. Write an algebraic expression for the distance traveled. We already know that d is equal to r times t. Now in this case, d will be equal to the rate, but the time is given in minutes. So we're going to have to say minutes divided by 60 in order to turn that into hours. Now let's interpret and use the distance formula. Byron lives in New York and will be attending college in Atlanta, Georgia. The driving distance between the two cities is 883 miles. Byron knows that the speed limit on the highway he will travel will vary from 50 miles an hour to 65 miles an hour. He figures that he will average about 60 miles an hour on his trip. At this average rate, how long will he be driving? And express your answer rounded to the nearest tenth of an hour and to the nearest minute. So again, we start with that distance is equal to rate times time. Now, if we're just trying to figure out what time is, then we divide both sides of the equation by r, giving us d divided by r will give us the time. So in this case, we get 883 will be divided by 60 to give us 14.716. Now that 6 just keeps repeating. So if we round this to the nearest tenth, we wind up with 14.7 hours. So we have 14 hours and the 0.7 hours. What we're going to do is we're going to take this 0.716. If we were to multiply it by 60, then we will get 43, and that's going to give us our minutes. So we're looking at 14 hours and 43 minutes. Now, let's check our understanding. Danielle drove from Atlanta, Georgia to Denver, Colorado, which is a distance of 1,401 miles. If she averaged 58 miles per hour on her trip, how long is her driving time to the nearest minute? Now, we start with the distance formula of d is equal to rt, but we want to know what t is, so both sides are divided by r. This means that we have 1401 divided by 58. This is going to give us 24.15517.241. Now we're going to take this whole decimal part and we're going to be multiplying that by 60. And that will give us 9.3. So this trip will take 24 hours and 9 minutes. Kate left Albany, New York and traveled to Montreal, Quebec. The distance from Albany to the Canadian border is approximately 176 miles. The distance from the Canadian border to Montreal, Quebec is approximately 65 kilometers. If the entire trip took 3.75 hours, what is the average speed of the trip? Kate's average speed can be reported in miles per hour or kilometers per hour. To report her speed in miles per hour, we're going to convert the entire distance to miles and change the kilometers to miles, multiplying by the conversion factor 0.621371. So 65 times 0.621371 will give us 40.389115. The distance from the Canadian border to Montreal is approximately 40.4 miles. Kate's total driving distance is the sum of the distance of Albany to the Canadian border and from the Canadian border to Montreal. So 176 plus 40.4 will give us 216.4 miles. Now we're going to solve for rate. We already know that this 216.4 miles is equal to d as the distance. And we know that the time traveled is 3.75. Since d is equal to r times t, and we're trying to find r, we're going to divide both sides by t, so that d divided by t will give us r. This means 216.4 divided by 3.75 is r, or 57.7 is equal to r. So Kate traveled at approximately 58 miles per hour. Following the same reasoning, we could determine the kilometers per hour. Now, let's check our understanding. In example 3, could Kate's miles per hour have been calculated by multiplying her miles per hour by a conversion factor? So we already know that her average rate was 57.7 miles per hour. The real question is, can we multiply this by 1.60934 to get the approximate kilometers per hour? And when we do this, we get 93 kilometers per hour, which is actually the kilometers if you were to go back and solve number 3 for kilometers. Now, let's use the formula for the relationship between distance, fuel economy, and gas usage. Julian has a hybrid car that averages 40 miles per gallon. His car has a 12-gallon tank. How far can he travel on a full tank of gas? The distance traveled can also be expressed as a function of the fuel economy measurement and the number of gallons used. So the distance could be equal to the miles per gallon times the number of gallons. This would be the same for kilometers, where we would say kilometers per liter times liter. Therefore, the distance that Julian can travel on one tank of gas is the product of the miles per gallon and the tank size, meaning the distance would be equal to 40 times 12, giving us 480 miles. So when traveling at an average speed of 40 miles per hour, one full tank of gas in Juan's hybrid car will take him approximately 480 miles. Now, let's check your understanding of this. And Lily drove a total of 500 miles on G gallons of gas. Express her fuel economy measurement in miles per gallon as an algebraic expression. Well, since we know how far she drove, and that is 500 miles, and if we divided it by G, the number of gallons used, we would actually find out exactly how many miles per 1 gallon was used. When Barbara uses her car for business, she must keep accurate records so that she'll be able to be reimbursed for her car expenses. When she started her trip, the odometer read 23,787.8. When she ended the trip, it read 24,108.6. Barbara's car gets 32 miles per gallon. Her tank was full at the beginning of the trip. When she filled the tank, it cost her $24.06. What price did she pay per gallon of gas on fill-up? Begin by computing the distance Barbara traveled. Find the difference between her ending and her beginning odometer reader. This means subtracting 23,787.8 from 24,108.6 to get a 320 mile 0.8 trip. Now, Barbara traveled 320.8 miles, and since her car gets 32 miles per gallon, we can determine the number of gallons used on this trip. This is saying that distance is equal to the miles times the number of gallons. This means that 320.8 is equal to 32 times G. So when we divide both sides by 32, we get 10.025 as our value for G. Barbara used 10.025 gallons of gas on this trip. Her total gas bill was $24.06. If her total gas bill was $24.06, divide the total amount by the number of gallons used to get the price that she paid per gallon. Barbara paid $2.40 per gallon for this fill-up. Now, let's check our understanding. Suppose a person begins a trip with an odometer reading of A miles and ends the trip with an odometer reading of B miles. If the car gets C miles per gallon and the fill-up of gas for the trip cost D dollars, write an algebraic expression that represents the price per gallon. First thing we would need to do is figure out how far the trip was, which would mean that we would do B minus A. Now we know how many miles that she traveled, so we could divide that number by C. Then what we would want to do is take the cost of the trip D and divide it by that entire fraction that we have already come up with. David is driving to Mexico on vacation. He noticed that gas cost $14.25 Mexican peso per liter. What is the equivalent in US dollars? So David must find the currency exchange rate. The currency exchange rate is a number that expresses the price of one country's currency calculated to another country's currency. Up-to-date exchange rates are available on the internet. Currency codes are often used when referring to exchange rates. Currency codes for US dollar is USD, and the currency code for Mexican pesos is MXN. David needs to know what one USD is worth in MXN. For the time of his travel, one US dollar was equal to 18.66 Mexican peso. Divide the value of the foreign currency paid for gas by the exchange rate. So he paid $14.25, and if we divide this by the exchange rate of 18.66, which is what we're using for this problem, it would be more updated as you watch the video, of course. This will give us approximately 0.76. Each liter would cost him about 76 US. He knows there's approximately 3.8 liters in a gallon, so he can multiply 0.76 by 3.8 to determine the equivalent gas price if he purchased it in the US as per gallon. So the price of 14.25 Mexican peso per liter is approximately $2.89 per gallon. Now let's check our understanding. On a trip to Canada, Angie noticed that the average price per liter was 1.28 Canadian dollars. If $1 US is equivalent to approximately 1.39 Canadian dollars, what is the equivalent gas price per US dollar? So we can take their price of 1.28 and divide it by ours of 1.39. This will give us approximately 0.921. So this is giving us a price as liters. So we're going to need to multiply this by 3.8 to turn it into gallons. This will give us 3.499 or $3.50 per gallon. David knows that the price of gas in his hometown is about $2.30 per gallon. How can he compare this price to the price paid in example 6 per liter? David needs to express the U.S. gallon price as a U.S. per liter. There are approximately 3.8 liters in a gallon, so we're going to divide the price per gallon by 3.8 to determine the price per liter. So 2.3 divided by 3.8 will give us approximately 0.61. So his hometown gas price is equivalent to about 61 cents per liter. So gas is more expensive in Mexico, being that is less than the 76 cents per gallon in example 6. Now, to compare the price in peso, we're going to multiply the amount in US dollars by the exchange rate. The exchange rate for that problem was 18.66. This is going to give us 11.38. The gas in his hometown would sell for about 11.38 Mexican peso. Just as the comparison in US dollars showed, the comparison of Mexican peso showed that at this particular time, gas is more expensive in Mexico because 11.38 is less than 14.25. Now let's check our understanding of this. In the example 6, check your understanding, Angie knew that the price of gas in her hometown was $2.50. What is the equivalent price in Canadian dollars per liter? What we want to remember from that problem is that 1 US dollar was equal to 1.39 Canadian dollars. So what we're going to do is we're going to take that $2.50 per gallon and divide that by 3.8. This is going to give us 0.65789. So we can round this to approximately 0.66. If we multiply this by 1.39, then we get 0.9174, or approximately 92 cents per liter.